Okay, so in section 1.4, we're going to start by building functions from other functions. It sounds complicated. It's not really that awful. You're going to use the operations that you would use on numbers, like addition, subtraction, multiplication, division, and we can perform these operations on functions. So there's a couple of notations for the sum and the difference and the products and the quotients. Sometimes they'll put parentheses around the two functions that you're adding together. Sometimes they may not. And really all you're doing is you're taking function f and you're adding it to function g, just like you see here. And as I said, they might write this in a different form. They might write this as f plus g of x, but it means the same thing. So they might have these parentheses around it, they may not. Same thing with subtraction. If you subtract the two functions, it's just f minus g. And again, they might write it this way. That one's a little light to see. Product, multiplying two functions together, they might write it this way. They might write it as f of x times g of x. They might just write fg of x. They might also put just a dot in between. Later on, they're going to put an open circle in there. So this I would kind of avoid. They'll either write it this way or this way. And then finally, the quotient, f over g of x, is just f of x divided by g of x. And again, they might write it without parentheses around the f and the g. So they're just telling you to go through and perform the operations on these functions here. And the last piece they talk about is domain. And the domain for your new function has to be the part that overlaps for your original two functions. So anything that's excluded from one of the domains will be excluded from the domain for your two functions added or subtracted or multiplied or whatever it happens to be there. So let's try a few of these. Like I said, they're really not that bad. So the first one, f of x equals 2x plus 3. G of x is negative 3x. So they said, what do you get if you add these two functions together? So f of x is 2x plus 3 plus g of x, which is negative 3x. And then just simplify these. You'll get negative x plus 3. So that's what f of x plus, f plus g of x is equal to. Subtraction, we do the same thing. So f minus g of x, that's going to be f of x minus g of x. Right, and combine some like terms there. You have minus and negative, so that's plus. So we have 5x plus 3. The next one, you have f times g of x. You're multiplying these two functions together. Times g, distribute through your parentheses, negative 6x squared minus 9x. Right, and then finally division. Let's see here. So division, so I would have 2x plus 3 divided by negative 3x. Now they talk about the domain a little bit. And the domain, what they're saying is, so find the domain for each. So f of x is 2x plus 3. So the domain for that, you can put anything you want in for x. Right? No values that would give you square root of a negative or dividing by 0. Same thing with this function, g of x. Your domain is everything. Negative 3, you can multiply by any number there, you'll get a real number. So when I add the two functions together, my new domain is the same thing. It's just their intersection, negative infinity to infinity, what they have in common. Same thing for subtraction. Right? And if you look at the outcome, y equals negative x plus 3, it's a line. Y equals 5x plus 3, that's another line. Y equals negative 6x squared minus 9x, it's a parabola. Same thing, domain, negative infinity to infinity. Now this one, the only thing that is an issue for this one is now since you're dividing, this denominator can't equal 0. And if negative 3x equals 0, that happens when x is 0. So my x can't be 0. So that's the only value that's eliminated from that domain there. And again, we could write that as negative infinity to 0 and 0 to infinity. All right, so that's the only thing they might ask about domain. Some of the beginning homework problems, they ask you what's the domain for the new function. Second example, same idea there. So if we go through and we find the sum of these two functions, f plus g of x would just be x squared plus square root of x plus 1. Just add the two functions together. For subtraction, x squared minus square root of x plus 1. Multiplication, x squared times square root of x plus 1. I'm just going to erase this part. And then division, same idea there. For division, I would have x squared divided by square root of x plus 1. So for this, if we look at the domain, the first one here, my domain for, put it down here, for f of x, well, f of x is equal to x squared. So my domain for this will be anything. I put anything I want in for x. For g of x, I have square root of x plus 1. Well, square root has to be greater than or equal to 0. So this number underneath has to be greater than or equal to 0. So if x is greater than or equal to negative 1, those values will give me square root of either 0 or a positive number, real numbers. So what these two domains have in common, or the intersection of these, would be all of the values greater than or equal to negative 1. So that would be negative 1, oops, with a bracket, to infinity. All right, the values for negative infinity to positive infinity fall within this interval here. So my domain then for letter A would be just that, from negative 1 to infinity. If I subtract these two values, same thing. Domain would go from negative 1 to infinity. Same thing if I multiply. Domain could be any number from negative 1 to infinity. Now this one, the only thing that I have to worry about is the denominator can't equal 0, so that x plus 1 underneath the root has to be just greater than 0. It can't be equal to 0. So my values have to be greater than 1. So my domain for this one, instead of being bracket negative 1 to infinity, it's going to be parentheses, negative 1 to infinity. So not including negative 1. And that's just because you have a denominator for that. So make sure you understand the process of just add, subtracting, multiplying, dividing the functions. If you're a little unclear with the domain part, don't worry about that so much. We'll pick up on that as we go. But it's more important that you can do this part, the add, subtract, multiply, divide part. All right, we're going to skip a little bit here, flip to the next page. We're going to look at some compositions of functions, but we're going to look at them in terms of numerical values that we're plugging in. So compositions of functions are just a function within a function. So this is the notation that you're used to seeing, f of g of x. This little circle here, this open circle, that's kind of the old school notation of it. F of g of x means the same thing. I prefer the parentheses notation because it sort of implies do this first and then work your way out. This little map's kind of interesting. It tells you if you have a number that you're plugging in for x, you start with this first function g, plug it into your function g, you get an outcome, and then you're going to plug that outcome into this function f, and that gives you this f of g of whatever the number was. That's what they're trying to tell you here. So you take the number, you plug it in, the outcome you get, you plug it into the next function. So we'll do this, the f of g of x and g of f of x, these two examples tomorrow. But we're going to use these same two functions, but we're going to evaluate them for a couple numbers. So we did this some in the summer packet here. So if you look at this first example, we're going to find, let's do f of g of 9. So what that means is we're going to start with our function g. Here it is. So starting inside here, we're going to plug in 9. So we would have square root of 9, which is equal to 3. We're going to take this outcome then, and we're going to plug it into this outer function f. So this number we took out, and we replaced it with the 3. So we're going to go to the function f. And in this function f, where you see an x, we're going to take it out and plug in 3. So 3 squared is 9, and 1 gives me 10. So f of g of 9 is equal to 10. Let's try one more of these. So let's look at g of f of 2. So we'll start inside here, f of 2. Go to your function x. We're going to take out the x and replace it with 2. 2 squared is 4 minus 1 gives us 3. We're going to work our way outside that function. So now we're in the function g. This thing we're going to take out and replace it with the 3 that we just got. So my function g says take out the x and replace it with this number inside here, which is 3. Let's try 1 or 2 more if we have time here. Try to beat the bell. Let's do f of g of 0. Okay, so we start inside with the function g. We're going to plug in 0. So g of x is square root of x is square root of 0, which is 0. We'll take that outcome, and we're going to plug it into this outside function. So f of, this comes out, we replace it with what it's equal to. And we go to that function f, and everywhere you see x, you take it out, and you're going to plug in 0. We get negative 1. So f g of 0 equals that negative 1. And we're going to do just one more because I want you to see that you don't always get the same outcome. So if we flip this thing around here, so if we do, let me just squeeze it in here, g of f of 0. Doesn't mean we're going to get the same answer of negative 1. So let's start with f. So f of 0 would be 0 squared minus 1, which gives us negative 1. Working our way out, the function g, so I'm going to plug in this value into my function g, so g of negative 1. This comes out, the negative 1 goes in. So if you go to your function g, it's square root, take out your x and you replace it with negative 1, you get an imaginary number. We're just dealing with real numbers right now. So this one has no solution, no real solution, and this one gave us negative 1. So the idea is that you see that the two functions are not, the property is not commutative. Just because f of g of 0 gives you an answer doesn't mean the other way around gives you the same answer. All right, so that's what you're going to look at in the homework problems for this first part, 1 through 14 all. For those, make sure you go through and you do the addition, subtraction, multiplication. If you can't figure out the domain part, that's okay, but you should be able to add, subtract, multiply, and divide the functions there, and then we can look at the domain separately. And then the last couple of problems, 47 and 48, those two are just multiple choice questions, so they kind of wrapped up at the end there. And then a couple of these, it looks like number 11 and 12, 11, 12, 13, and 14. They write the notation for this f of g of x. So the same problems that we just did, so this g of f of 2. Let's see if that reset my ink here. No. All right, so you're going to write this g of f of 2. Let me see if I can get this g of f of 2 right here. Instead of writing it in the form that we had right here, they're going to put the number right after it here. So we use the little circle there instead. But the process is the same then. You'll see what I mean, the notation. They don't use the parentheses notation, they use the dot notation there. All right, that's all that you have then for those homework problems. Make sure these notes are filled in completely. If you missed anything, go back and fill them back in because I will check them tomorrow and make sure that they're complete. There's no excuses.